Hello, this is me again, Engineer Jerome Agas, taking a Master's in Computer Engineering, specialized in Data Science and Engineering at Polytechnic University of the Philippines. My subject is Intelligent System and Robotics with the supervision of Dr. Ryan Evangelista, and our task is to dissect a paper review in Genetics Algorithm or GA. Okay, a paper review in GA. The title of this research is a genetic algorithm for feature selection in lower limb pattern recognition. So, letter A, who has done the work or the author? So, first is the Robert V. Schulte from the Roessingh Research and Development and Schede, Netherlands, and the Department of Biomedical Signals and Systems, the University of Twente, Schede, Netherlands. Okay, so the second author is Eric C. Prinsen from Roessingh also, Research and Development, and Schede, Netherlands, and the Department of Biomechanical Engineering, University of Twente and Schede, also in the Netherlands. Oh, the third author is Hermie J. Hermans, also from Roessingh Research and Development again, and the Department of Biomedical Signals and Systems, the University of Twente and Schede in Netherlands. Okay, the fourth and the last author is the Jaap H. Burke from Roessingh Research and Development in Schede, Netherlands, and the Department of Biomedical Signals and Systems, the University of Twente and Schede, Netherlands. Okay, so letter B, what were their goals or objectives? Okay, first, the goal of this research is to demonstrate the capabilities of a generic algorithm and come up with a feature set that has a better performance than the state-of-the-art feature set. Okay, so the second is the goal of the study was to investigate the use of a genetic algorithm for future selection to enhance myoelectric control of the lower limb. Okay, so they are examine the control of the lower limb of the body. Okay, so first we need to define what is genetic algorithm. So genetic algorithm search the solution space using a nature-inspired process based on the genetic evolution. So the genetic algorithm uses a population of candidate solutions which are evaluated based on their fitness. A solution with a higher fitness more likely to continue in the genetic process, whereas poor solutions are phased out. This solution encode the problem at hand and are comparable with chromosomes containing a certain genes. Okay, so it looks like genes. If you know what is a genes, so you may familiar with this genetic algorithm. So it looks like a genetic. Okay, so these chromosomes undergo crossover and maturation operations to evolve into a new population of solutions. This process is repeated until the process of converge to a solution or the maximum number of the iterations is reached. Okay, so thus they are many solutions to update every table or every page. Okay, so that's what genetic algorithm is all about. So letter C, what were the research and questions, if any? Actually, not applicable because this is an experimental type of research. Letter G, what were their methods in terms of, but not limited to? How have they gathered the data? So this is number 1, and the subtopic of the number 1 is who are the participants. Actually, the person who control or who gate related activities while measuring the electromyography or EMG and kinematics. So these are the 10 able-bodied subjects. The next subtopic or the sub-question is, how is the data gathering set up? Of course, collecting from an able data set. And the second data set is collected from MyLeg-Roessingh database. These are all already collected. Okay, so the next question or the next sub-question is, what are the tools and techniques used in the data gathering? Of course, the EMG and the kinetic measurements. So they have an instrument or the devices that you are able to use to measure the motions of the lower limb or the body. The number 2 of the letter D, how do they form the data set? Okay, so the sub question on the number 2 is, how do they clean the data? So by evaluating the remaining test set and on the online benchmark dataset enables against the state-of-the-art feature set. So they are comparing the two dataset, right? So the next is the number 3. How do they process the data and or how do they develop a model for the fuzzy logic? This is simple because the solution encode the problem at hand and are comparable with the chromosomes containing certain genes. These chromosomes undergo crossover and mutation operation to evolve into a new population of solutions through a genetic algorithm. So through the genetic algorithm, they develop also the fuzzy logic because the chromosomes talks about the small. So if the measurement is Boolean method, so they will not get the precise answer. So of course the dataset here is in decimal. So that's why I conclude that the dataset is used for fuzzy logic. Okay, it is applicable to the fuzzy logic also. Okay, so the letter E, what were their findings? The result showed that the feature set based on the selected features of the genetic algorithm outperforms the state-of-art set. The overall error decreased up to the 0.54% and the transitional error by 2.44%, which represent a relative decrease in overall errors up to 11.6% and the transitional errors up to the 14.1%. Although these results were not significant, the study showed that the genetic algorithm is capable of searching a large feature space, that the systematic feature selection shows promising result for lower limb myoelectric control. Okay, so that's what their findings in this paper. And the letter F, what were the gaps in their studies or findings? So what will be the gaps? Okay, so based on the findings, the finding combination of best performing features of genetic algorithm applied in lower limb pattern recognition. Okay, so that's all, and I would like to thank the audience who are watching in this video about the GA or the genetic algorithm. So see you next time. Bye bye.